Hello and welcome to the Daily Space for today, June 3rd, 2019. I'm your host, Dr. Pamela Gay, and I am here to put science in your brains. Today we have a variety of stories coming to us from near and far. Before I get started, though, I want to remind all of you that CosmoQuest X is more than just Twitch. It's more than just social media. We are your place to learn and do science. And right now, we are teamed up with the OSIRIS-REx spacecraft to map out the asteroid Bennu. And we need your help. Right now, that little asteroid, it is, I think the best way to put it is it's perplexing us with its sheer number of rocks. And it's our job to map out all those rocks, map out all those boulders, find the rare craters, and along the way, help the OSIRIS-REx team figure out where it's going to be safe to touch down their spacecraft and grab a sample of the soil. So click on over, if your screen allows, to bennu.cosmoquest.org in another browser and help us map out Bennu while you learn what's new in space and astronomy today. And speaking of what's new, I'm going to start with a tale of, well, a pair of asteroids. Thank you for the bits. Here you go. I'm going to start out with a tale of a pair of asteroids that got a bit close to home. The image on the left is an actual image taken by the Very Large Telescope down in Chile. On the right is an artist's rendition of what these asteroids might look like. Now, while that image on the left might look, well, kind of fuzzy and boring, it's actually super impressive. This asteroid is a kilometer and a third wide. So it's kind of tiny. It's a distance that I can bike ride in like 10 minutes. So it passed us on May 25th at a distance of 5.2 kilometers, 5.2 million kilometers. It's when it was at that distance, which is about 14 times the distance to the moon, that this image was taken. And being able to resolve the asteroid like this is the equivalent of setting up a telescope in Paris, looking across a flat planet we don't actually live on, and resolving a building in New York City. So imagine the distance between Paris and New York. And imagine being able to see a single building at that distance. That's the equivalent of what was done here. So this is an amazing piece of science. And this particular pair of asteroids poses absolutely no harm to the Earth. It is classified as a near-Earth object because it got kind of near. And during this particular encounter, the International Asteroid Warning Network actually used it for a cross-organizational observing campaign to essentially practice what to do if there is an actual asteroid coming a little too close to home in a way that might pose a danger. The name of this asteroid is 1999 KW4. That means it was discovered in 1999. We're really kind of boring in how we name things. And this is just an amazing piece of science. So go team go. Again, this was observed from the ground using the Very Large Telescope. They used the SPHERE instrument on the Very Large Telescope on the ground. So yes, Larry in the chat, I see you. You are right. This is a drill. This is only a drill of the International Asteroid Warning Network. Now, moving out a little further from home, we have news coming to us from the Chandra X-ray Observatory about a galaxy that appears to have been left alone since the very first days of the universe. This is a fairly Isolated, non-interacting, boring galaxy. It is named Marconian 1216. That means it's the 1216th item in the Marconian catalog. And looking at this system, astronomers have been able to figure out that it is pretty much just stars and dark matter, and that it finished being built 10 billion years ago. All the stars in this particular galaxy formed in the first few billion years of our universe. And since then, this galaxy, unlike our own and unlike most of the galaxies that we've observed, it hasn't absorbed another galaxy. It hasn't shown any cannibalistic tendencies. It's just hanging out by itself in the way that it originally formed. This means that it formed quickly, it formed all in one giant go, and that it is extraordinarily rich in dark matter. Now, what this tells us is our current understanding that galaxies formed in two different ways is appearing more and more to be true. Some galaxies like this one formed in the early universe when dark matter collapsed, drew in visible matter, baryonic matter, and formed a galaxy. And then it just hung out. I'm a galaxy, not growing or anything else. In other cases, we had small systems grow, and these small systems came together, combined, grew, grabbed more small systems, combined and grew. And so it's now looking more and more like galaxies formed both in what's called a bottom-up model and a top-down model. They formed both all at once and systematically through the growth of small systems. This is one of those things that early on we thought everything formed one way or the other. And it turns out that what I was taught in grad school is completely wrong. And that's kind of awesome. One of the reasons that we keep doing science is because we don't know everything. And as I often say, the actual universe keeps proving itself to be more creative than we are. Now, in our final story of the day, I have a newly recovered and restored and scanned video of film of a 1900 solar eclipse. And what's amazing is we're actually able to see in this video a little prominence on the sun right here, and we're able to see that changing corona over time. This particular eclipse occurred on May 28th, 1900. It was imaged by a magician. Magicians have always been fans of science because that's often how they figure out how to do their magic. This particular magician was named Neville Maskelyne, and he was on an expedition with the British Astronomical Association to North Carolina. This isn't the first time he traveled the world to try and, well, photograph an eclipse, or in this case, video an eclipse. In 1898, he had gone to India. Unfortunately, the canister of film from that particular expedition was stolen. So it turns out that scientific data is sometimes considered of thievable value. Now, this was no particularly easy feat then or now. Trying to get good photographs of eclipses is very difficult because getting the exposure time right is a challenge as the sun radically changes in brightness as it goes into the eclipse. Not only that, but he had to, by hand, build an adapter for his camera for his telescope. This is something that nowadays we just get on optcorp.com and order on the internet. Now, he did this all by hand. While he was thought to have done a great deal of film and photography, this is the only film by Maskelyne that appears to have survived. It was in the archives of the Royal Astronomical Society, and it was painstakingly restored. And one of the amazing things about film is it's the grains of the chemicals that decide the resolution of the film and the size of the film itself. And this video that we're looking at, it's actually a scanned 4K film of a solar eclipse. That's something that we can do with film that we're only starting to be able to do with our digital cameras. It's just kind of amazing. So that's today's science. We have a historic eclipse that we get to view in detail. We have a May 25th asteroid approaching the Earth. We have in the chat nebula cluster subscribing. Thank you. Eddie so totally can't catch. And we have a galaxy filled with dark matter. I'm now going to scan through the chat and answer your questions. Please remember to type at CosmoQuest X while you type those in. And while you're typing in your questions, I'm going to remind all of you that CosmoQuest is a production of the Planetary Science Institute working in collaboration with Youngstown State University. We are brought to you by you. If you like what you see, please consider making a donation. The Planetary Science Institute is a 501c3 nonprofit, and your donations are tax deductible where the law allows. Now, we understand not everyone can contribute, and that's fine. I have limits on what I can do myself, and I give where I can, but I can't always do it. There's other ways you can really help the show. You can help us by doing science, by mapping rocks and boulders at bennu.cosmoquest.org. You can get the word out, tell your friends about us, help us increase the number of people who are here every day watching this show. We have fantasies of someday making partner here on Twitch. So spread the word, do some science. We just want you to learn, and we're so glad that you're here. Okay, I am now going to scan through the chat and see what questions there are I can answer. I'm going to scroll all the way up to the top, and I'm going to say, Guido, it's always good to know what you're making for dinner, and I'm going to have leftovers for lunch as soon as I'm done recording. Hello, our Instro. Yes, we are your people. I'm glad to see you here. Hello, everyone. There's too many of you here to list by name. Thank you for the follow, Open Cage 5, and thank you also, Semadia Job, for the bits, Nebula Cluster for resubscribing 3 months in a row, and for your 100 bits. Oh, and DPI 209 has bacon, and now I want bacon, and I don't have bacon. Okay. Not finding questions, scrolling. There's no Hanny here today. Hanny always has questions. Larry's asking, who first found the orbit that this latest near-Earth object? I don't know. I didn't actually look it up. Let me see if I can find it real fast for you. As I said, it was found in 1999. But this is the kind of thing that should luckily be just a click away. Scrolling. It was discovered by Lincoln Labs Linear Project. So thank you for the bits. This is another one of the many linear discoveries. Okay, let's see what other questions we have in here. Thank you to my moderators for being an amazing group of mods. Yeah, this video, Planetary Pan, is amazing. You're right. Larry asks, did you say how old the galaxy was? So the galaxy that I talked about This is Markarian 1216. It formed about 10 billion years ago. So it formed in the first few billion years of our universe, which currently we're not as sure how old it is due to issues in measuring the expansion rate of the universe. But that's a different show. Oh, I'm still struggling with my voice. Sorry about that. So it's an old galaxy that just hasn't undergone any more star formation since then, or nommed on, rather, it may have had star formation. It hasn't nommed on any other galaxies or dust since it first formed. So orange is like so CosmoQuest. Bacon and frozen burritos. Yes, those are some of my favorite foods. The cheap frozen burritos that you probably got in grad school for like $3 for a dozen. They're still one of my favorite foods. I will never grow up, apparently. Also love the waffles. You guys know that I do this show hungry, planning to eat lunch as soon as I'm done. You are such tempting individuals. So CosmoQuest is asking how far away the object is. So the press release didn't give the distance. Let me see if I can look it up real fast. It can't be too far away based on how well it's resolved. So there's a difference between how old something is and how far away something is. Sometimes they're the same if we're looking at it form in the extreme distance. But other times it can be fairly close. The information is not coming up. Okay, here we go. Let's see what I have in this web page. It does not want to tell me. So I am not at all sure how far away this is. Aha, here, I found it. It was in the very bottom of a website. It is roughly 295 million light years away, so it's fairly close in terms of galaxy distances. So this is a close, super old galaxy, which is kind of awesome. It makes it easier to study. So Veronica Cure is asking, have you seen the beginning of Good Omens? They talk about the age of the earth. I've read the book. I haven't seen it yet because I want to be able to like just sit down and enjoy it. And I am so behind on everything from being sick. Don't get bronchitis, guys. That I haven't had the time to just enjoy it. I'm saving it to savor it. I did go see an Amanda Palmer concert last Thursday. So I saw Neil Gaiman's wife perform. Does that count for anything? I don't know. So Sema Didajab asks, does this galaxy have all the same elements, atoms as our own? Yeah, that's the amazing thing, is the physics here is the same everywhere. The stuff here is the same stuff that's everywhere else. It's just the amounts of stuff that change. Thank you, Veronica, for the bits. Stella is the laziest dog ever. She is so lazy. Thank you, guys. Thank you so much. Okay. So Larry Weird asks, CosmoQuest, extra credit question. Explain the redshift factor Z as it relates to distance and age. Okay, so this particular object is 295 million light years away, which is a redshift of 0.0213. And distance, redshift, and expansion rate are directly related. I don't remember the equation off the top of my head. Let me see if I can derive it. So Hubble constant is meters per second per kilometer. There must be another factor in there somewhere. I'm just going to cheat and I'm going to look up the equation. And the way it works is, if you know how fast the other factor is the velocity that something appears to be moving at. That's where you get the velocity term in. I remembered it before I looked it up. don't want to explain the relativistic. I just want the regular one. It only wants to give me the, aha, there we go. So the redshift of an object is related to its velocity along the line of sight divided by the speed of light. I completely lied about there being a factor of h in there. Completely lied. Sorry about that. So it's a ratio. You look at how fast something appears to be moving, you divide that by the speed of light, and that gets you the factor of z. Now, the reason we talk about things in factors of z is we can measure how fast galaxies are going by their Doppler shift. We know the speed of light because we can measure it in a lab. And the ratio of them gives us a simple number to talk about. So as you get further and further away, the velocity at which something appears to be moving goes higher and higher and higher. So my microphone is at a redshift of 0. I can't see it moving away from me. The nearest galaxies that aren't gravitationally bound to us have redshifts close to 0, but slightly positive. As we look at the most extreme objects that we can see, we start to get redshifts that are 6 or 7, and there's relativistic corrections in that so that nothing's moving faster than the speed of light. And it's just a way of, now that I'm remembering things that I haven't talked about in years, it's a way of getting at the distance of something without having to know, or get at the relative distances of things without having to know the rate at which the universe is expanding. This is something that, while you do have to take into account relativistic effects as the universe is expanding faster and faster, since you are always taking into account the same things, something that's closer will always have a smaller z, something that's further will always have a larger z, and it gives you the relative distances without having to know the absolute distances if we don't know the expansion rate. And you have to know the expansion rate to get at the actual distances if it doesn't have a supernova or something like that that allows us to use a different method to measure the expansion rate. And I wasn't at all prepared to explain that, so I hope I didn't lose you too badly, and now I will answer more of your questions. So Mike Cassidy says 200 million light years away means it might not exist today. Since this is a galaxy, it'll still exist. Unlike stars, galaxies have a tendency to stick around until the end of time. Yeah, bronchitis is the worst. It, like galaxies, seems to stick around forever. Oh, I know self-care, Veronica Cure, I just suck at it. With launching Bennu mappers, it's just like, I want to science so hard, and it's making me get sick, or stay sick. So z greater than 1 is visible to us. That's where you're having to take into account relativity. So that stuff isn't actually accelerating away at the speed of light once you take into account all of the corrections. Lots of maths, Paranor. Yes, that is the way to look at it. Lots of maths. I'm actually going to show you the maths. A lot of scientists take time to make sure that the equations that are on Wikipedia are correct. And I actually just pulled up the equations on Wikipedia. So you can see here is the equation. Yes, you can see my mouse. And let me make that bigger. Whoa, that did not go as intended. No, I don't want that version. That's the version I want. Okay, so here it is for low redshift, where you don't have to take into account relativistic corrections. And then as you expand it out for higher z's, it becomes this. Yeah. So all the corrections. If z is bigger, do we get faster running zombies? I'm not going to answer that question today. I'm going to ponder it and leave it for the horror writers among us. Okay, so that's all I've got for today. I just realized I'm not actually showing you the equations. There are the equations. So go ahead and take a look at the scary equations that I had to solve way too much while doing my dissertation, and I'm slightly embarrassed that I thought there was a factor of h in there initially. Thank you for being here. I am now going to remind all of you, go map Bennu. Bennu needs you. Go map rocks. Go map boulders. Find the occasional crater. Together, we can keep the OSIRIS-REx spacecraft safe. All told, there's going to be 4,500-ish images going into Bennu mappers. We have until July 10th to get everything mapped so that the OSIRIS-REx spacecraft can do follow-up imagery on some of the most promising sites. Check it all out. We need you. We need you. I hope to see you all there, and check out the Discord. We're having some great conversations about the cool stuff that people are finding. So thank you. And I am going to prepare to run the credits and ask you who I should raid today. If you don't state opinions, I'm going to pick someone from the Knowledge Fellowship to pass everything over to. It looks, so that's a rerun. I'm not going to raid a rerun. So Serpent AI is around, and he hasn't been around for a while, and he is a friend of CosmoQuest. So I am going to raid Serpent AI. So wherever you are in the world, have a fabulous morning, evening, or afternoon. Thank you for everything that you do to support us with your subs, your science, and spreading the word. We couldn't be here without you. If the weather allows, get outside and look up. Bye-bye.